This tutorial will show you how to use EDPIV to analyze a group of images. So we'll start off by launching EDPIV, and we'll consider a group of images that I made with the simulation tool that I showed you in another tutorial. And as you can see from my directory here, I have 10 particle image pairs stored in this directory. So what I need to do is make what's called a file list of the images that I would like to analyze. So you can do this. I'll show you the file structure in a second. You can do this with you can just type it up yourself, or you can ask EDPIV to do it for you. So if I ask ED to do that, I go to Statistics, and the top 3 boxes in Statistics show you how to create the list file. So the first box is the recording type required for PIV image file list. If I select this is basically a flag that can have values 1 to 5. If I choose 1 means that there's 2 laser flashes in each image, and so consequently 2 images of each particle in the image. In the old days, we used that for double pulsed PIV. Almost nobody does that anymore. So choice number 2 is when image 1 correlates with image 2, and image 3 correlates with image 4, image 5 correlates with image 6, and so on. This would be conventional frame straddling PIV. And that happens to be the mode in which my simulated images were created. Flag choice 3 is also a useful choice, and that one is if frame 1 correlates with 2, frame 2 correlates with 3, frame 3 correlates with 4, i.e. the time between each frame is the same. And that's oftentimes used when you're using white light illumination and a video camera to do PIV. All right, so not the case here, but often used. 4 and 5 I've never used. All right, so now in order to make EDPIV generate this list file, I have to tell it where to make the list file. So I'll go to Input Files, and I choose my the directory in which I have my images, which is this directory that you see here. Now I want to change this. Initially it's looking for star.tsk file types. I'm going to change that to all, and I'm going to choose one of the BMPs that's in that directory, and I'll click Open. And what happens is EDPIV parses the file name and directory, and you see here it chooses the directory that those pictures are in, and then it chooses star.bmp. So it's going to grab all the BMPs out of that image. Now, if you have out of that directory. So if you have multiple experiments mixed up in one directory, it's going to grab all of those pictures together. So you want to be sure that each directory has only one set of images, or images from one experiment in it. It's also auto-populated this output, and you can see that it's suggesting to put the file in a you're going to put this list file into a file that's called file.list, and that's fine with me. But if you don't like that, you could click on this radio box and change that output file name. Okay, so everything's set. In order to make it go, I click File List, and if you noticed in the background here, the list file just appeared. So file.list, I've set up .lists on my computer such that they are recognized as notepad files, so I can just double click that and I can see what the list file looks like. And so you see 10. In the first line there's 2 numbers. So 10 is the number of pairs of images, and 2 is that flag value that I chose as 2. And then I should have 10 pairs of file names. So I have shear 1001 underscore 1 .bmp and shear 1001 underscore 2. That's the first pair. And then shear under 1002 underscore 1 is, and shear 1002 underscore 2 is the second pair, and so on. And so I told you, you can build this up on your own if you want to, just cut and paste or type your file names in there. But I find it's much easier to have EDPIV put this together for you. One thing to note, that these file names are all sorted in alphabetical order. And so if one file happens to be missing, well, let's say for some reason you deleted shear 1005 underscore 2, if that's missing for some reason, then it's going to try to correlate shear 1005 underscore 1 with shear 1006 underscore 1. And there's no particles in common between those two, so you're not going to get any correlation. Okay, so let's go back, let's close this, and I need to load in that list file, and I do that with the image group command. So I click image group, and it brings me up to the directory that I've most recently been in, which is my sim images directory, and there's my file list. So I double click on that, and what you see is the front of the first page of EDPIV brings up the image as usual, but instead of just showing one image, it's now showing, there's this counter box down here, and I can use that to flip from one image to the next. Okay, so now I go to evaluation and go to settings, and you'll see, okay, let's look. The main changes in when I've loaded in a list file are in this dialog box right here, in this box right here. So I have three choices now that are these two. The first choice, single image per pair, that was always there. That was the default choice when you have just two images. But two new choices have been ungrayed and made black, and those are image group processing and average function. So image group processing will process every pair of images in your list file and produce a velocity field for every pair of images in your list file. So in my case, I have 10 pairs of images. I will get 10 velocity files. Another way of processing these is shown here as average function. This is what we call correlation averaging. So you will average, at every measurement point, you'll average the correlation function, build up an averaged correlation function, and find the peak location for that averaged correlation function, this is a very useful technique when your particle concentration or signal to noise ratio is low. So I will start out, as an example, I will do image group processing, and I'm going to leave this on 32 by 32 pixel windows. I know that the shear flow has a maximum displacement of 5 pixels at the top and the bottoms, so I can leave that at 12. I'm going to do window shifting with leaving the velocity files in M2. Choose central difference interrogation, continuous window shifting, and 4 pixel image correction done in a CDIC fashion, central difference fashion. Okay, and then I'll click close. And then I'll click start. And the first thing that comes up is a dialog box that asks me if I want to filter my particle images. And I won't do that in this demonstration. Then the setup for the multi-pass processing comes up, and I will just I'll do 3 primary iterations, and I'll set the convergence criterion to 0, and I'll click go. Okay, the evaluation is finished. I click OK, and what we see here is the calculated velocity for a single pair of images. Alright, if I come and look at my directory, now we see that for, let's say, shear 1001, those are my 2 BMPs, my 2 bitmaps that were used to create the picture, that were used to create, that were correlated. And then there's shear 1001 .dat, and then shear 1002 .dat, and so on. So those .dat files, those are my velocity information. So, and you can see I've created a velocity file for every single pair of images. Now that's one way of processing image sets. The other way is to do correlation averaging, and EDPIV can do that as well. So I will load in an image group. I'll load in the file list, and same thing as before, you see that file list. I'll go to evaluation, turn off grid points and vectors so I can see what the picture looks like, and go to settings. I want to do multipass. This time, instead of doing the image group processing, I'm going to do average function. So I'll click average function, and as I mentioned, you're going to produce just one velocity file here. I'm going to use the same interrogation parameters, and I'll click close, and then click start. Again, the filtering dialog box comes up. I click OK. I'll do 3, put the convergence criterion at 0. Alright, I'll do that, and click OK. Now you'll notice the interrogation box scanning around the picture, and you'll see the status bar growing. You see the statistics here. The noise has gotten converged very quickly, approaching 0. Alright, so I'll click OK. I can turn the vectors on, and what you see is a very nice smooth velocity field. And if we go down and look at the directory here, I list this by date. We haven't saved any velocity files, and that's because there's only one created, and it's in M0. So if I wanted to save that, I would go to evaluation and click save. Alright, that's all for this tutorial.